Dear children, in the last video we were discussing about algebraic expression, and in this video we will see some of the practical applications of algebraic expressions. That is, practically where are we using this algebraic expression in maths. Okay, so practical applications. The first application which we are going to see is perimeter formula. So you all have come across this word perimeter, right? So let's see how can we derive perimeter of different shapes, which is in the form of algebraic expressions. Okay, so first one which we are going to see is equilateral triangle, perimeter of an equilateral triangle. Okay, so this is an equilateral triangle, right? All the three sides are equal, right? So suppose L is the length of one side of an equilateral triangle. What is the value of the perimeter? L plus L plus L. That is, perimeter is equal to 3L, right? So this 3L is an algebraic expression, right? If we give the value of L as 1 or 2 or 3, we will be able to find the value of the perimeter, right? So this is an algebraic expression. Similarly, for a square has four sides, right? Four equal sides. So let's take L as the length of one side. So what will be the perimeter of the square? L plus L plus L plus L, that is 4L, right? This 4L is also an algebraic expression, right? So these perimeter formulas are all given in algebraic expressions. Okay, now the third example is a regular pentagon. Okay, so regular pentagon will have 5 sides, 5 equal sides. So if L is the length of one side, we can see that the perimeter is 5L, right? So these are the three cases where perimeters can be expressed in the form of algebraic expressions. Okay, now next one is area formula. Okay, so the first one is square. So let A be the length of one side. So what is the value of the area? It is A square, right? So this A square is again an algebraic expression, right? So next one is a rectangle. So rectangle, we need two dimensions. This is length, this is breadth, right? So if L is the length of the rectangle and B is the breadth of the rectangle, what is the value of area? LB. LB is the value of the area. Okay. Now similarly, take a right triangle. Let B be the base of this triangle and H be the height. Okay, so the value of area here will be BH by 2 or half BH. Okay, so this is again an algebraic expression. So in all these cases we can see that if the value of variables are given, we can find out the value of area or perimeter of any shape, right? So these are the some of the practical applications where we are using algebraic expressions to form formulae for different shapes, okay, for area or perimeter of different shapes. Okay, now the next topic which we are going to see is patterns. Okay, so we can we can use algebraic expressions to find out or to fill up a pattern. Okay, so for example, let's take a geometrical pattern, or let's take a square here. Okay, a square is made up of how many line segments? 1, 2, 3, 4. Okay, so one square is made up of 4 line segments, right? 4 line segments. Now take the next case. This is a square just like this, and we are adding one more square here. Okay, so these are 2 squares. So just count how many line segments are here. 1, 2, 3, 4, 5, 6, 7. So 2 squares, we need 7 line segments. Okay, similarly, take 3 squares. This is 1 square, this is the next square, this is the next square. Okay, so how many line segments we need here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 squares, 10 line segments. Okay, so in general we have to form an expression which is used to find out the number of line segments which are required to make n number of squares. Okay, did you understand? So we have to find, or we have to formulate an expression or a formula to find out how many line segments are required to make n number of squares. That is, for making 1 square you need 4 line segments. To make 2 squares you need 7 line segments. To make 3 squares you need 10 line segments. For making n squares, how many line segments are required? Okay, so for making n squares, you need 3n plus 1 line segments. So just substitute this here and see if you are getting the answer. Here n is equal to 1. So if we put n here, 3 into 1 plus 1 is equal to 4, which is the answer here. Okay, so if we put n is equal to 2, n is the number of squares, right? So n is equal to 2, how much will come? 3 into 2 plus 1 equal to 6 plus 1, 7. Okay, so you need 7 line segments. So if you are making 3 squares, how many line segments do you need? 3 into 3 plus 1 equal to 10 line segments. Okay, so in general 3n plus 1 line segments are required for making n squares. Okay, this 3n plus 1 you can find only through trial and error method. Okay, so you have to think a bit and find the formula. Okay, so this is also an algebraic expression, right? 3n plus 1 is also an algebraic expression. Now hope you all understood this. Okay, now let's take another example. Let's take this pattern. Okay, so this is a P which is made up of how many line segments? 1, 2, 3, 4, 5. 5 line segments. 4 1p. Okay, now these are 2p's. So how many line segments are required? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 line segments are required for 2p's. Okay, similarly for 3p's, how many are required? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 line segments are required for 3p's. Okay, so for making np's, how many line segments are required? You will get the value as 4n plus 1. Okay, so the easiest way to do is to see the first one. First, for making 1p, you need 5 line segments. So you have to calculate 4n plus 1 means 4 into 1 plus 1, you are getting 5 here, right? So if you look at the first p, it will be the easiest one from where you can find out this formula. Okay, then you have to do trial and error substituting the other values of p's in this. Okay, now for making np's, you have to do 4n plus 1. Now try substituting this. 4 into 1 plus 1, that is 5. 5 line segments, correct? Now for making 2p's, how many are required? 4 into 2 plus 1, 9 line segments, correct? For making 3p's, how many are required? How many line segments? 4 into 3 plus 1, that is equal to 12 line segments. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, this is 13, right? 4 3 are 12 plus 1. So 13 line segments. Okay, so this is also right. Did you all understand? So this 4n plus 1 is the formula for finding out the number of line segments required for making np's. Correct. So this 4n plus 1 is also an algebraic expression. So just like geometrical pattern, we can also form number patterns using algebraic expression. For example, let's take this example 3, 6, 9, 12. Okay, so let the first number be n. Okay, so what is the second number? 2n, like 2 into 3 equal to 6. What is the third number? 3n. What is the fourth number? 4n and all. Okay, so now how will you find the 10th term? 10th term, that is 10 into n, right? So the first number n is equal to 3. So what is 10n? 10th term will be 30, right? What is 100th term? Will be 3 into 100, that is 300. Okay, just like that. Even if you want to find the 1000th term, what is the 1000th term? 3000. Okay, so by using this formula, you can find out any number in this series. Okay, and this is a geometry. This is a algebraic expression, right? So algebraic expressions are used in finding the number pattern also. Now let's take another geometrical pattern. Okay, so these three are different shapes, one with 4 sides, one with 5 sides and one with 6 sides. Okay, and I have drawn diagonals also in these. Okay, so we have to find the maximum number of diagonals which can be drawn in a shape with n sides. Okay, so here n is equal to 4, so for 4 sides, for a figure with 4 sides, maximum number of diagonals is 1, right? Again, for a figure with 5 sides, maximum number of diagonals is 2, and for a figure with 6 sides, maximum number of diagonals is 3. Okay, so in general, what is the formula for a figure of n sides? How many number of diagonals can be drawn for a figure with n sides? Okay, so the answer will be n minus 3. So if you substitute here, you can see that is for 6 sides means 6 minus 3 is 3. For 5 sides means 5 minus 3 is 2. And for 4 sides means 4 minus 3 is 1. Okay, so n minus 3 is also an algebraic expression which is used to find the number of diagonals which can be drawn inside a figure with n sides. Okay, is it clear? Okay, thank you. Bye bye.